Yes, students. Okay. Now we will be doing the another topic from the chapter capacitor, that is grouping of capacitor. Okay. I haven't told you yet that capacitor symbolic way representing is this. Means this represent a capacitor. Okay. These two parallel lines. Okay. In class 10 you have learned that the resistors may have connected in a circuit in a series and parallel way. Similarly, the capacitors can also connect. One form is series connection, and another way is parallel connection. Okay, just like, because these capacitors are circuit elements just like the resistors, right? And in the market there are so many capacitors available. So this capacitors can be connected depending upon the requirement. We can connect either in series or in parallel, and sometimes a mixed form also comes, but purely series and parallel only. Now we'll come one by one. Okay, series. Okay, series connection. In the note, things have been given clearly. Um, so I'm not going to write much lines. What are the important points, that only I will be discussing. Like suppose I have, let's say, series. Suppose I have three capacitors, say C1, C2, okay, and let's say C3, okay, let's say, and they are connected. Okay, serially they are connected, yes or no? Serially, when they are connected, then this is known as a series. Okay, now they have to be connected with a supply, right or not? So this is the one. Okay, these are capacitors having capacitance C1, C2 and C3. Now this battery, okay, this battery, let's say if Q charge goes from here, say, okay, then this Q charge, what will happen? It will store here Q. Now because of the induction, right, because of the induction, the inner side of it will be what? Minus Q. Okay, then the outer side of it will be what? Plus Q, right or not? This plus Q has a path, so this plus Q will not going to saddle, but this plus Q will going to go here. Okay, will go here, right? This plus Q will induce charges. This plus Q will affect another plate, right? And this plus will induce what? Minus Q on the interior and plus Q on the outer. But this plus Q has a path to go, right? Right or not? Then this plus Q will be what? Will plus Q will go here. Okay, then again similar, inside will be minus Q, outside will be plus Q, and this plus Q has a path to go, so it will come here. Okay, so this way the charge will circulate. Okay, I will repeat again. Suppose the battery providing Q charge, battery only circulates, but let's say Q charge. Okay, current is the flow of the charge only, right? So when the current goes, means the charge is flowing. Okay, so if this Q charge is going, let's say this Q comes here to this side of the plate only, right? This side of the plate only. When this side of the plate gets positive, then this plate will affect another plate. Now because of the induction, what will happen? The interior of the plate will become negative and the outer will become positive. The interior will stick to it because of the attraction, but this plus Q has the path to go. So what will happen? This plus Q will go here. Okay, and this plus Q will induce over here, then minus Q and plus Q. Minus Q will remain here, the plus Q will go here. So what is the, why I'm telling you that in the capacitor, when they are connected serially, charge, number one, charge is same. Charge is same, right? Charge is same for all the capacitors. Very important point to note. All right. Okay. Now coming about the potential. Okay. This battery, let's say, is V potential. All right. V potential means I can say this part as potential V, and another is means what? 0, right? V is the potential difference, right? Potential difference means what? The difference. This can be 12, this can be 0. Suppose I have a battery of 9 volt. Okay, I can say this one is 9, I can say this one is 0. All right, or I can say, all right, I can call this one 12, right? I can call this one 3, right? It's up to me, right? Still the difference is 9, right? I can even say 15, and I can even say, for making it 9, how much it's needed, right? 6, right? Still the difference is, so the easiest way is one to take full, another to 0. So the potential difference is V, means this side is V, another is 0, right? Now this is, there is no resistor connected. Now this is also V potential, this is what? 0 potential, right? But in the capacitor there will be the drop, right? Isn't it? Because what? Capacitance is what? Charged by potential, right? Isn't it? Or I can write potential is equal to capacitance charged by capacitance, right? Now as the capacitances are the difference, that means the potential will also be different in each the capacitor, right or not? You understand the logic behind. Okay, now capacitance is equal to charge by potential, right? Now potential is equal to charge by capacitance. Now each capacitance are different, right? So in series the potential difference will be there across each capacitor. Okay, now this V, okay, this V is equal to what? V1 plus V2 plus V3, right or not? Right? Okay, clear or not? Then V is equal to, can I write Q by C? Let's say this is the equivalent capacitance. Okay, equivalent means what? Equivalent means instead of 3 capacitor, if I make 1, that is equivalent. Then V1 will be what? Charge on C1 is the same, capacitance C1, this is equal to Q by C2, and this is Q by C3, right? Now Q cancels out. That means what? When the capacitance are adding up in series, then the reciprocal of them is only adding. Okay, so this is the expression of when the capacitor is connected in series. Okay, I'll repeat again. When the capacitor is connected in series, the charges across each capacitor is the same. However, because of the serial connection, the drop of the potential will be different, right? The drop will be different. The total potential is the drop across each capacitor, right? Then we did, and it comes out a reciprocal. But remember, you need to remember it. Okay, say for an example, I'll take an example for it. Okay, suppose I have a 3 capacitors. Let's say one is one is 3 microfarad, another is 4 microfarad, okay, and another, let's say I'm just taking it 5 microfarad, one more I can add. What is the equivalent capacitance? The question is how much its equivalent capacitance. Then they are in series, right or not? When they are in series, then how they will add it? The reciprocal of it. Okay, so this is what? 1 by 3 plus 1 by 4 plus 1 by 5. Okay, then this is what? EQ, and this is equal to 3 4 12, the 60, right? 60 is 20 times. This is 4 will be of 15 times, and this will be of 12 times, right? Then CEQ, this is equal to 35 45 45 47, right? 47 by 60. Then CEQ is equal to what? 60 by 47. I'll not do the calculation. Microfarad. Okay, So it will be 1 point some value. Okay, so when they are in series, the capacitance actually reduces. All right, see, the lowest one was 3. Okay, but the equivalent is just 1 point something. All right, so when you are having a number of capacitors and you want to lower it, that means what, you need to make the connection serially, right? Okay, this point keep in your mind. You need to keep this one in your mind. Okay, now coming about the another type of what to say, another type of connection, which is a parallel connection. This one is parallel connection. Suppose I'm taking in general 3 capacitor, but if you want you can take more or less also, 2 also it will work. Okay, suppose I have 3 capacitors. Again, let's say C1, C2 and C3. Okay, I hope this is clear, right? Now let's see, here is a supply. Okay, and the supply gives the potential of V, and let's say a charge Q has come from here. All right, now this charge, when it goes at the junction, what will happen? The charge will have 3 ways to go, or I can say the current will have 3 ways to go, right? So Q1 here, Q2, right, Q3, right? Now this Q1, this will become Q1, this will become minus Q1, then this one will become what, Q1, this one will become what, minus Q1, the other side of it will be plus Q1, so here it will be what path there is, so plus Q1 will come. This is also the same thing, Q2, and this is Q3, right? So what we what with this Q is equal to what, because the from the total charge, the charges divides, right? From the total, it's divide at the junction, right? So the total charge is Q1 plus Q2 plus Q3. What about the potential? See here, this is a V and this is 0. This is normal way. Now this is, what is the potential here? V, right? What is the potential here? 0, right? Okay, right? Okay, now V and 0, how many capacitances are there? 1, 2, 3. That means C1 is also having the same potential, this also have same potential, this have also the same potential, right? Right or not? Because this C3 is in between V and 0. So what is the potential here? The potential here is V. What is the potential here? V. What is the potential here? V, right? It is the same potential, right? So in parallel, you need to keep in your mind, potential is same. Potential is same. I have given you in notes, so I'm not going to explain it much. Okay. Now Q is equal to CV, right? Now this is equal to what? This is equivalent. V potential is the same, right? Q1 will be what? Q1 is what? Q1 is for C1, right? Q1 is C1, so this will be what? C1 V plus this is what? C2 V plus C3 V, right? Fine, V cancel out. So what is the equivalent capacitance? The equivalent capacitance is C1 plus C2 plus C3, right? So in this case, when they are connected in parallel, okay, when parallelly connected, the capacitance directly added up. Okay, let's suppose if this is 2, this is 3, this is 4. Okay, see. Okay, let me use, suppose I'm repeating, suppose this is 2, this is 3, and this is 4 microfarad. Okay, because microfarad is the most common one. All right, then what is the equivalent capacitance? Equivalent capacitance is equal to what? C1 plus C2, directly addition, nothing you have to do. Then this will be 2 plus 3 plus 4, and this will be what? 9 microfarad. Okay, so in this case, one more thing, the capacitance is what? Increases, right? The maximum capacitance of the individual was 4, right? And the capacitance is higher than that. Okay, so if you want to increase the capacitance, how have to be connected? They have to be connected in parallel. Okay, if you want to reduce the capacitance, you have to connect in series. Then what? In the text, in your notebook, I have given some numericals. Even the numericals which are important for the Z and NEET exam, for those also I have done it. But considering the exam point of view, previously I was not new about the omitted portion, but MBSC is not giving any guidelines for the grouping of capacitors. Simply it's included, so I'm not going to do the difficult questions. Okay, I'll be stressing on the simple questions. Okay, so let me just get it from the copy. Okay, I'll do that only without. Okay, all right. One I will do. Okay, here in the text notebook, I mean, let's see, there is 3 parallelly connected capacitors. Okay, 2 and 3. Okay, they are connected in parallel. The figure may not be exactly. This is connected to a 4 volt. It is there in your notebook. Okay, 4 volt. Then this is 1 microfarad, another is 2 microfarad, and another is 3 microfarad. Okay, now the questions, what are the questions? The questions are, number 1, equivalent capacitance, or what? Total capacitance. Okay, number 2, charge across each, charge across each capacitor, charge across each capacitor. That means I need to find how much is the charge across here, and across here. Okay, then we even need to find the potential difference, and even the energy stored in 1 microfarad capacitor. That you can easily do it. Okay, now total capacitance, they are in parallel, right? What is for parallel? Okay, for parallel, what? The capacitance is directly addition, right? C1 plus C2 plus C3, right or not? This is number 1. Then this is equal to 1 plus 2 plus 3, right? Then this is what? 6 microfarad, right or not? Because what? These they are in series, in parallel. Okay, now coming about number 3. I'm not doing 2. First I'm doing potential difference. Potential difference across each capacitor. Okay, this is what? 4, this is 0, means what? This is what? 4, this is what? 0, right? So across 3 microfarad, across 3 microfarad, what is the potential difference? 4 minus 0 is what? 4, right? Across 2 microfarad also, what is it? 4. Across 1 microfarad also, what is it? This is also 4 volt in all the case, right? It's same. So this question is only checking whether you know the concept or not. Okay, now coming about charge across each capacitor. Okay, number 2, charge is equal to what? C into V, right or not? right? Now the charges on each capacitor will be different because the charge has have divided, right? Now C I know, let's say, let's find this charge across here. Let's find it Q3. Okay, so Q3 will be what? Q3 will be what? C3 into V. V is the same after all. So this is micro is 10 to the power minus 6, right? And volt is what? 4. So this is what? 12 into 10 to the power minus 6. Charge is what in coulomb? Came or not? Easy. Okay, students. So I'll give you some homework to do on it. You see this video, try to understand. If you not understand, follow the other online classes group also. Thank you.